7.3, new information, logs. We got these logarithms. When we're writing from exponential to log, it's the inverse of an exponential problem. So again, anything with a base, and then we have an unknown variable in the exponent, that's an exponential problem. The log is what is the inverse of this. So if this is my number here, and let's say this was equal to 25, and you might already know the answer, which you should. However, we can rewrite this. This base is the same base that we have when we write logs. So we write the log. The base is this little itty-bitty number right here. And so if we do log base 5 of whatever it's equal to, so in this case, 25 would be equal to x. Lucky thing about you, you can plug this straight into your calculator. You have an option. Not everybody has the exact same depending on your calculator, but you do have an option where you can change this 5, or else I'll be showing you in class how you can do it differently. So these first set of problems, it's just rewriting in a log form. So we have, in this case, it might be better if you just look at what's my base. So I have log base 10, so that's a little 10, of whatever it's equal to, so 100 is equal to 2. The second one, here's my base, so it'd be log base 3 of 81, so whatever the exponential is equal to your exponent. So try C and D by yourself. For these, we're just going to plug these into your calculator. I'm going to actually show you here how we can do it without our calculator, but we will be using our calculator. So first, I can rewrite this as an exponential because this is an unknown. This is what we don't know what this is equal to. I can rewrite this as 8 to the x power, because I'm just have the same base, is equal to 32. I'm going to rewrite both of these. 8 is the same thing as 2 cubed, and we still have that x in the exponent. 32 is the same thing as 2 to the 5th. Once you have two problems and the bases are the same, so both of these are base 2, you can set their exponents equal to each other. So x will be equal to 5/3. So question number 2, this is equal to x, so my base here is 5, so 5 raised to whatever it's equal to 125. This is the same thing as 5 to the x is equal to 5 cubed, so x would be equal to 3. I want you to try to do them the long way, but I will be showing you tomorrow in class how to do them with your calculator. So one thing we have is a common logarithm. So if you look on your calculator, your graphing calculator, you have a log button, and that's always going to be a log base 10. So this is what it looks like, and if there's no number written right here, if there's no base, it's always assumed to be 10. So without showing the actual 10, that's what that is. So this is a long question. Basically, it's asking what's the intensity of the other earthquake. So this is my equation that's given right here. We want to be able to find what this intensity is, the difference in intensity, difference because it's dividing. So what we have to do is do the log, because that's, I'm just looking at the equation given in the formula. So if you didn't read it yet, you should read it. You have I1 over I2 is equal to the 9.3 minus 8.7. So the smaller earthquake minus the larger earthquake. So we have log, I'm just going to change this to I, just to make it easier, of 0.6. Now I want to solve this. I can rewrite this as an exponential function. Remember, this is base 10. So I'm going to go 10 to the 0.6 power is equal to that I1 over I2. If you do, that's I2, 10 to the 6th power in your calculator, you get 4. So that new earthquake was 4 degrees larger in intensity. So you should try the next one, the B, by yourself. And now we're getting to log functions for graphing. So first I'm going to graph x or y 10 to the x power. So this is review. I'm going to make a table. You can plug this into your calculator if you want to find these numbers. But we have 0 and 1. We have -1, 1/10. We have -2, 1/100th. Again, you could put these as decimals, 1, 10, to 100. I'm not going to get to the 100. So plot those points. And it looks something like this. So when I do my domain here is all real numbers. My range here, y has to be greater than 0. and my asymptote would be equal to y is equal to 0. So now I have my log. I'm going to graph my log of x right here. Log is the inverse. Remember, it's the inverse of this. Now we can find this table on our graphing calculator, or we already have the table to the left. And remember, the input of the original is the output of the inverse. So I'm just going to flip-flop these numbers. So 1 over 100, negative 2. 1 over 10, negative 1. 1, 0. 10, 1. And I'm going to plot those points. Now, if you remember from chapter 6, the inverse is always the opposite for domain and range. So my domain here, it's my x value now. It still will always be my x, but whatever the range was for my original, that's going to be my domain of my inverse, so it's greater than 0. My range is my domain, so whatever my domain was is going to be my range. In this case, all real numbers. And I know that because this will be going up forever, this will be going down forever. That's why I know the y can be anything. My asymptote, again, it's I did not spell that right over there, but it's flip-flop. So over here it was a y equals, now this is a x equals. I have an asymptote at x equals 0. The reason why there's no number that I can put in and that to get a negative x value. I can't put negative x value into my equation. So this is at x equals 0. And again, think of it as the inverse. Now for these points right here, I would never expect you to do this in your head. You can always use your graphing calculator to find out what these tables are. So if you graph this, and if you're not sure how to change the base on your log, I'll show that in class. However, another way that you could think about this, if you weren't sure how to type this into your calculator, you can think of this as the inverse of this function would be equal to 3 to the x power. So if I think about it that way, I can fill in, if I plug 0 in for 3 to the x, I would get 1 out. If I plug negative 1 in, I would get 1/3 out. Plug in negative 2, I get 1/9. So what I'm doing is plugging the numbers into my inverse, so it's easier for me to do it in my head. Otherwise, you can use your graphing calculator to fill out this table. If I plug 2 in to this equation, or 1 in, sorry, I would get 3 out. If I plug 2, I would get 9 out. So plot those points. So it looks something like this. You have to know from the original exponential, you have a y equals asymptote, but here I have an x equals asymptote. X cannot be 0. So my domain, x has to be greater than 0. My range, y can be any real numbers. I can get any number out. And my asymptote, x is equal to 0. It will never cross that 0. So I want you to try the other one, this next one by yourself. Again, if you don't know how to change the base in your calculator, you can do with the inverse, like how I just did the problem before. Now our transformations are the same here that we have been dealing with for every single function. However, you have to be careful because these transformations are going to actually be doing different things. This h will still move it left and right, just like it has done before. However, since it's with the x, this moves the asymptote left and right. So when I'm looking at this equation, I can already know what my vertical asymptote is. My asymptote is going to be, will be at x equals 3. Why? Because this is a negative 3, so this is always opposite. This is where I would highly suggest just to use your graphing calculator to figure out your points. And actually, that's where we're going to start tomorrow, is to do A and B so that you know where you can find them on your graphing calculator. You, I'm talking about you. You have a great, grand, wonderful part of the day that you're having right now.